Okay, so this warm-up was covering 5-4, which is your sum and difference formulas. A quick review on the patterns. So if it's sine, then remember it's sine, cosine, cosine, sine. And you keep the positive, negative the same. So if this is a plus, then it's a plus in between. If it's sine with a minus, then it's sine, cosine, minus cosine, sine. If it's cosine, then the pattern is cosine, cosine. And you change the sign. So if it's plus, you change it to minus, then it's sine, sine. If it was cosine with a minus, then it's cosine, cosine, plus sine, sine. And then if it's tangent, and let's say it's u plus v, then it's tangent of u plus tangent of v. So the sign in the top matches. 1 minus tangent of u, tangent of v. And if it was tangent of u minus v, then it's tangent of u minus tangent of v over 1 plus tangent u, tangent v. So all that you want to have memorized. All right, so the first one says to find the sine, the cosine, and the tangent of the angle 195. So what are two things that you can add together that are in your unit circle to get to 195? 150 and 45. How many of you do that? Okay. Anything else? Okay, that works too. You could have done a difference too. Remember, you can do any of those as long as they add up or their difference is that 195. So the sine of 150 plus 45 would be sine of 150, cosine of 45 plus cosine of 150, sine of 45. My 150 is the last thing I hit before the x-axis, which is negative root 3 over 2 and 1/2, and then my tangents negative root 3 over 3. So this would be sine is 1/2, cosine at 45 is root 2 over 2, cosine at 150 is negative root 3 over 2, sine at 45 is root 2 over 2. And I get root 2 minus root 6 over 4. So remember I said that on your test it's open-ended. You can leave it like that, but keep in mind that in like a week, you're going to be taking a week from Friday. You're going to be taking a midterm, some of you, and the midterm's multiple choice on this part, and that would take out the root 2 over 4. So it would say root 2 over 4 and then 1 minus root 3. So just keep in mind that those are both the same things. All right, then you get cosine. So cosine of 150, cosine of 45. This time we change the sign, so it's minus sine of 150, sine of 45. And the cosine would be negative root 3 over 2 and root 2 over 2. And then the sine, 1/2 root 2 over 2. And I get negative root 6 minus root 2 all over 4, which would be root 2 over 4 times negative root 3 minus 1. And then the last one is tangent. So tangent of 150 plus tangent of 45 over 1 minus tangent of 150, tangent 45. So tangent 150 is negative root 3 over 2. root 3 over 3. Tangent of 45 is 1. 1 minus negative root 3 over 3 times 1. So this becomes negative root 3 over 3 plus 3 over 3, so that I can combine that into 1. Negative root 3 plus 3 all over 3 is my numerator. This becomes 1 plus root 3 over 3, and that's 3 over 3 plus root 3 over 3. So 3 plus root 3 over 3. And then I want to flip it. Those cancel. Negative root 3 plus 3 over 3 plus root 3. And then multiply by the opposite. So I get negative 3 root 3 plus 3 plus 9 minus 3 root 3, which is negative 6 root 3 plus 12, all over a squared. A is 3 squared minus the square root of 3 squared, which is 9 minus 3, or 6. And then I get negative root 3 plus 2. So there's only so many combinations of numbers, okay? If you've got tangent and then you've got root 3 over 3 as one of your, obviously that's the least pleasant one, but there's a chance you could get it, so you want to make sure you're ready for any of it. All right, and then it said the opposite, right? Now we're finding the exact value by condensing this. So the pattern is sine, cosine, cosine, sine, which means it's sine. And then with sine, we keep the positive negative. So this would be 120 minus 60, or the sine at 60 degrees, which is root 3 over 2. And then the tangent one, we match the sign in the top. So tangent 25 plus 110, which is tangent 135, second quadrant at the over 4, which means it's 1 and it's negative because it's in the second quadrant. Questions on those? These are obviously not on my unit circle, so I have to find coterminal angles. So if you start by subtracting 360, you end up having to do it 3 times before you get something that's less than 360, which is 45 degrees for the first one. And then same for, I think you subtracted 4 times. For the second one, you get 120. So now I'm doing sine of 45 plus 120. So that's sine 45, cosine 120, plus cosine 45, sine 120. And then 45 is root 2 over 2. Cos 120 is negative root 3 of, no, sorry, negative 1/2. And root 3 over 2. So the cosine there is negative 1/2. Cosine at 45 is root 2 over 2. Sine at 120 is root 3 over 2. And I get negative root 2 plus root 6 all over 4, which could be switched like that. Okay, order doesn't matter as long as the sign's on the right one. So then B was comparing it to what would happen if you distributed sine. The whole point is that you can't distribute sine. It's not the same answer. So if I find the sine of 45, which is the coterminal here, I'd get root 2 over 2. And then the sine of 120 is what we found up here, root 3 over 2. And then if I add those together, I get root 2 plus root 3 all over 2. And these are not the same answers. So this is kind of just like proving the point that you can't distribute sine in. You have to find it using the sum and difference.
Did you already pass the 10 question?
All right, so this says, given the sine of u is 40 over 41 and the cosine of v is negative 3/5, and both are in quadrant 2, that means both of them have a negative x and a positive y. So if u is here and this is 40 and this is 41, if you did the work on that, what'd you get for the side, adjacent side?
9. Negative 9 or negative.
It should be negative, good. And then the other one, uv, this would be 3 and this is 5. This one's negative, missing side is 4. So if it wants cosine, it's cosine of the first, cosine of the second, change the sign, sine of the first, sine of the second. So cosine of that first one, the first one is this one now, would be negative 3/5. Cosine of the other one, negative 9/41. Sine of the one on the right, 4/5. Sine of the one on the left, 40 over 41. And then you get 27 over 205 plus 160 over 205. 197 over 205. 187 over 205. Next one, same thing. They give you the information about a triangle. Both are in the third quadrant this time, so we're moving left and down. Both the x and the y are going to be negative this time. So if this is u, sine would be negative 12, hypotenuse would be 13, missing side would be negative 5. Cosine of v, this is negative 15, this is 7, and the other side is negative 8. And then it's tangent, so it'd be tangent of the first plus tangent of the second over 1 minus tangent of the first times tangent of the second. Tangent of the first, which is the u, would be negative 12 over 5, or 12/5, plus tangent of the second one, 8/15, because they're both negative, over 1 minus 12/5 times 8/15. So then in the top, you got to change them so they have the same denominator. So it'll be 36 plus 8 over 15. 44 over 15. And then the denominator, 1 minus, multiply these out. 3 actually goes into this. 4, 5 times. So it's 32 over 25. 25 over 25. Negative 7 over 25. And then keep change flip. Questions? So if you got hung up on it, why? Like, where do you stop? This one, this isn't anybody in this class, but that one on the left could have been reduced. So I would just reduce it as you go, make your life easier. Okay. 9 and 10. So 9 said to verify the identity, use the difference formula and then simplify. So remember, if it says it on the test, it's going to be the same thing. It's going to say, use the sum and difference formulas to verify the identity. So you're going to have to expand it out. So if I look at the first one, it says 8 times sine 7 pi minus x. This is sine of a difference. So it would be 8 sine of the first one, cosine of the second one. Sine stays the same, so minus cosine of the first, sine of the second, equals 8 sine of x. So then 7 pi is an odd whole number, which means it happens on the left where negative 1, 0 is. This would be 8, sine there is 0, times cosine, minus negative 1 times sine. This is 8 times, this is gone, negative times a negative is a positive sine x. I get 8 sine x equals 8 sine x. Yep. 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 Oh, we have to fill in multiple parts? No, but that's how you do it. Yeah. Yeah.
For the first box, I just put 8 sine 7 pi minus x and we took this, right? Yeah.
Because it cancels out, right? Yeah. That's fine. Because you can simplify it in different ways.
So on the test, it'd be okay.
So on the test, like, I expect to see it's a verifying process. So I expect to see the whole thing because you're getting credit for verifying, right? So this is how you'll see, like, there's not a whole lot at the beginning of the test. I just did 1, like 5, 1, 5, 2, but then you're going to see it like this. You're going to see it in your solving where you have to replace it with a Pythagorean identity, that kind of stuff. Okay, this is 10. It said find the solution of the equation on the interval 0 to 2 pi. So this is an equation. So we're solving. This is like the 5.3 section, but it's involving two sums, one with cosine and then the difference with cosine. So if I expand this out, first of all, you could have divided everything by 4, and you could have gotten rid of it, and it would have been cosine of x plus 5 pi over 6 minus cosine x minus 5 pi over 6 equals 1. You could have distributed the 4 in after you expanded it, but you also could get rid of it. So then this is a sum with cosine. The pattern there is cosine, cosine. Positive, negative changes, so it's minus sine of x, sine of 5 pi over 6. That's that whole first one. Then it's minus, again, cosine, so cosine, cosine. That's a minus, so it becomes plus sine, sine equals 1. Now, I know nothing about the x values, but I know at 5 pi over 6, my coordinate point is negative root 3 over 2 and positive 1/2. So my cosine is negative root 3 over 2 minus sine of x times sine there, 1/2. This minus gets distributed to both. So minus, actually I'll wait on that so that I'll show the difference. Minus cosine of x, cosine of 5.6, of 5 pi over 6, negative root 3 over 2, plus sine of x, and then sine of 5 pi over 6, 1/2. Now I can rewrite that just so the values are at the front, so it's less confusing. Negative root 3 over 2 cosine x minus 1/2 sine x. This negative goes there, so negative times a negative is a positive root 3 over 2 cosine x. This negative comes here, negative 1/2 sine x equals 1. These cancel. Negative and negative 1/2 and negative 1/2 is negative 1. Sine x equals 1. Divide both sides by negative 1 and I get sine of x equals negative 1. And then it's giving you the interval. So on my interval of 0 to 2 pi, I want to know where sine, which is my y, is negative 1, which is at 3 pi over 2. If it didn't give me the interval, I would do 3 pi over 2 plus 2n pi. So there will be less straight up verifying and evaluating like you did in the beginning, like on your quiz, and more of it built into the equations, something like that, where you're solving using sum and difference or verifying an identity using it. So keep that in mind as you're like reviewing. There will be verifying, but there will be less of it like than what was on your quiz. Your quiz, you had a bunch. This stuff you already have written down. So if you want to take a picture, you can take a picture. We won't sit through and write it all down, but you know that if you are the type of person that needs to rewrite notes, that you need to rewrite this stuff. This is your reference for 5.1 and 5.2, but also remember that it comes back in 5.3 and 5.4 when we're solving our equations. So all of the reciprocal identities are there, the cofunctions, the even and odd, and then the Pythagorean identities. These are also all on the Quizlet, so you can practice them if you like flashcards. There is not a whole lot of the verifying from the beginning because we pulled verifying in on 5.3 and we pulled verifying in on 5.4, so you'll see it again that way. This should be a relative, like it's only 12 questions. It should be a relatively short unless you get stuck and you're stuck and you can't get past it, which is what some of you did on the quiz. You need to learn to get past and then go back to it if you've got the time. But don't get stuck on a problem for more than a couple of minutes. Just setting yourself up for failure. All right, then came, so these examples we actually worked out on the quiz review. Okay, these are the ones that are even. Okay, so you still need to know your even and odd functions, right? So that, wait, was that negative on that one? Yeah, this is a negative. So this is an even function, which means that negative goes back positive. It has no change on it. This is an odd function, which changes that cotangent to a negative cotangent, but there's already a negative there. So this becomes sine plus cotangent alpha cosine alpha. Now cotangent is cosine over sine, which becomes sine plus cosine squared over sine. And then I want to give sine the same denominator. So I'd multiply by sine and sine, and I'd get sine squared plus cosine squared over sine. What's sine squared plus cosine squared? 1. What's 1 over sine squared? Or 1 over sine? Cosecant. Any other ones we got stuck on that you can't figure out? Because honestly, I'd love to have been able to help you, but I couldn't figure out what you did half the time. It was super fun to grade these. Okay, so again, two separate fractions, right? This time you got to give them have a least denominator, which means this is going to get 1 minus sine in the top and the bottom. This cosine. These both get cosine, right? So then I get 1 minus sine of x times 1 minus times 1 minus. So it's minus sine x minus sine x plus sine squared x plus cosine squared x all over cosine. 1 minus 2 sine x plus, this is 1. That's 2 minus 2 sine x. Take out the 2. Bring it to the top. this is good because remember that there could be different directions, right? There's two different ways to deal with this, and one is if it's a multiple angle without an interval, and one's a multiple angle with an interval. So on your quiz, it was without an interval, right?
Yeah.
So you solve it. So I divide by 2, and I get tangent of 3x equals -1. So tangent is -1. Technically, fourth quadrant is all you need when you're adding on the interval, which would be -pi/4, or I gave it, if you did 7 pi over 4, I gave them both. So then it would be 3x equals -pi/4 plus n pi, or 3x equals -pi/4, 7 pi over 4 plus n pi. Then you've got to divide each side by 3. So x would equal, this is times a third, -pi/12 plus n pi over 3. Divide by 3. X equals 7 pi/12 plus n pi over 3.
Oh, I used the -1.
So the negative is fine. It should still been this.
No, and then like I put -1 where the pi/12 is.
Oh, okay. What? I gave either answer there.
Okay.
Now, test is going to be different. Test will say on the interval 0 to 2 pi. So everything in the beginning is exactly the same, but I cannot leave it with the plus n pi. I have to see if those numbers itself are in between 0 and 2 pi, and then I count them, and also add the interval that's there to see if there are more. So if this is the case, let's say I just use the one on the left, because they were both technically right. Let's just say I use the one on the left. Is -pi/12 in between 0 and 2 pi? No. It's negative, so I wouldn't even use that one. But I would take that one and I would say -12 or pi/12 plus, I make n1, so plus pi/3, which becomes 4 pi/12, and I get 3 pi/12. Is that in between 0 and 2 pi? Yeah, so I'd simplify it, but I'd keep it. Pi/4. Then I add again pi/3 or 4 pi/12, and I get 7 pi/12. Is that less than 2 pi?
Yes.
Yeah, so I keep it. And then I do it again. And I get 11 pi/12. Is that less than 2 pi?
Yes.
So I keep it. Add 12 again, it's going to be too big. No, it's not. 23 pi/12. I can do it one more time. So all of those are the answers that work. Yep.
Why does the tangent have to be in the fourth quadrant? Like at the beginning?
Because we add every half circle. So it's not that it's wrong to use the left side, it's that it's redundant. You've already stated that by adding n pi.
Oh, okay.
Does that make sense?
Yeah.
Okay. So I didn't mark it wrong. If people did both, I actually didn't mark it wrong. It's not necessarily wrong. I put okay by it probably,
Okay.
but just be careful.
Okay.
Just some examples of verifying, but you're never going to get the same one twice, so don't get it too attached. Just make sure you're practicing those. 5-3 came your solving. So remember that when you're solving, you're finding the solutions. There was 2 different kinds. Actually, I'm going to rewrite this down here. So there's 2 different kinds of solving. One, when you're given, actually 3 different kinds. One, when there's no interval. And so for sine and cosine, you add the 2n pi. And for tangent, you add the n pi. So for sine and cosine, you pull from your whole circle and then add 2 pi. For tangent, you pull from the right side of your circle, which you can either use the negative angles on that fourth quadrant or the natural ones. I don't care which ones you use. But for those, you only take half the circle and then you add n pi. Then there was interval, like 0 to 2 pi, with a regular equation. So anything but a multiple angle. And for these, you use your entire unit circle. And then there was the more complicated ones, which were the multiple angle, with an interval. These are the ones that you have to use both. The interval plus 2n pi or plus n pi, alter the interval with your multiple angle one, and then look at your unit circle. This is where you had to add your multiples of n pi to see if there were more options within that circle, okay? So if you had something like sine 2x equals 1/2. Obviously, it could get more complicated before that point, but you've gotten to this point, let's say. So the natural answer on this, without the interval, would be that 2x, everywhere sine is 1/2, which is positive pi over 6. So it would have been at pi over 6, and it would have been at 5 pi over 6, because that's where sine is 1/2. Plus your interval, 2n pi, plus your interval, 2n pi. But this multiple angle means something's attached to the x. So it could be here, it could be over 2, something like that. So I have to go through the next step, which would be to divide everything by 2. And I get x equals, this would be times 1/2 pi over 12, plus these cancel n pi. And then this would be 5 pi over 12 plus n pi. Now, because it gives you the interval, you actually have to see if these angles fall within that interval, which pi over 12 does and 5 pi over 12, right? They're bigger than 0, but less than 2 pi. But then I actually have to add on intervals of what's there. So I'm going to take the pi over 12, and I'm going to add where n is 1. So I'm going to add pi. Make it 12 pi over 12. I get 13 pi over 12. And I have to see, does that fall between 0 and 2 pi? It does. So not only am I keeping the original, but I'm keeping this. And then I would repeat that process again. And this time it's too big, so I know to stop. If it wasn't too big, I would have kept it. I have to do it to that one, and I have to do it to 5 pi over 12. 5 pi over 12 plus 12 pi over 12 is 17 pi over 12. That's less than 2 pi, so I keep it. If I add 12 to it again, it's too big, so I know not to keep it. So my answer is the original 2 that I got from my equation, which would be pi over 12, 5 pi over 12, then the 2 extra ones I found, 13 pi over 12 and 17 pi over 12. So that's if you have an interval and a multiple angle. Those are the complicated ones, okay? So I'm going to post your review today